Padmakant Dhage, Assistant Professor Electronics and Telecommunication Engineering. Today my topic is Flexray protocol in automotive network communications. Learning outcome: at the end of these sessions, student will be able to explain feature of Flexray, the architecture, frame format, comparison CAN and Flexray protocol, applications of Flexray protocol. Content: in these sessions we have to discuss introduction, feature of Flexray protocol, Flexray layered architecture, Flexray frame format, comparison CAN and Flexray protocol, advantages of Flexray protocol, applications, conclusion and references. Introductions of Flexray protocol. As a technology advanced, traditional bus systems like CAN, that means controller area network, were no longer sufficient to handle the demands of modern automotive applications. Flexray is a fast, deterministic and fault tolerant bus system for automotive use based on the experience of well-known OEMs, that means original equipment manufacturer. With the development of prototype application and the byte flight communication systems. In order to fulfill the requirement of active safety systems, byte light was further developed by the Flexray constraint, particular in relations to the time determinism and fault tolerance. Flexray is an automotive network communications protocol developed by the Flexray consortium to govern onboard automotive computing. Visual Sim Flexray library enables a system designer to construct model of complex standard and non-standard Flexray topologies. Features of Flexray protocols: high-speed data rate. That means Flexray offers high-speed data transfer with the maximum data rate of 10 Mbps. This allows for quick and efficient communication between various electronic control units, that is ECU. In the vehicle, the high data rate is particularly beneficial for safety critical systems that requires real-time and deterministic communications. Second feature, fault tolerant mechanisms. Flexray incorporates fault tolerant mechanisms to ensure reliable operation in the presence of fault or errors. These mechanisms include redundancy and error detections and signaling capabilities. By tolerating faults and maintaining systems reliability, Flexray enhances the overall safety and dependability of automotive control systems. Next feature, time triggered and event triggered modes. Flexray supports both time triggered and event triggered communications modes. The time triggered mode allows for deterministic transmission of data at predefined time intervals, ensuring precise timing and synchronization. On the other hand, the event triggered mode handles non-deterministic data transmission in response to specific events or conditions. This flexibility in communication modes enables the protocol to cater to various application requirements. Next feature, single and dual channel topologies. Flexray can be implemented in single channel or dual channel topologies. In single channel configurations, a single network cable connects multiple ECUs, similar to the multi-drop topology in other communication buses. Dual channel topologies, on the other hand, provide higher levels of fault tolerance and or higher bandwidth. These topologies enables designers to optimize the trade-off between cost, performance and reliability in the overall vehicle architectures. This one, Flexray protocol architecture. First one level is a topology level. The Flexray protocol defines a two-channel network, channel A and channel B. A node can be attached to one or both of these channels. If a node is attached to the single channel, it does not matter if it is channel A or channel B. The Flexray protocol allows for various bus topologies. This can be a point-to-point connection, passive, star, linear, passive bus, active star network, cascaded active stars, hybrid topologies and dual channel topologies. The Flexray protocol will support hybrid topology as long as the limits of each topology which make up hybrid topology, that is the star and bus topologies, are not exceeded. Second one level, interference level. Flexray support bus guardian of physical interface. It enforces error containment in the time domain and performs error detection in the time domain. Bus guardian interacts with the communications controller, that is signal monitoring and synchronization, and host processor configuration activation or deactivations error signaling. Third level, interface level. The bus guardian is used in Flexray protocol to protect the communications channel against the faulty behavior of the communication controllers. Each communications controller has a bus guardian. On the one side, the bus guardian should prevent the communications controller from accessing the communications channel outside its pre-allocated slots. On the other side, the bus guardian should guarantee that messages from non-faulty communication controller are correctly relayed. We identify 4 properties of the bus guardian. First one property is correct relay. If a correct communication controller sends a message, its non-faulty bus guardian relays the message. Second one, validity. If a non-faulty bus guardian relays a message, then all correct communications controller receive the message. Third one, agreement. If a non-faulty communication controller receives a message, then all non-faulty communications controllers receive the message. Fourth one, integrity. If a message is received by non-faulty communications controller, the message must have been sent by another non-faulty communications controller. Then next one, a protocol engine level. It consists of the static segment, dynamic segment, symbol window, and network ideal time, as shown in diagram. First one, static segment. The static segment is broken down into smaller sections called static slots. Every static slot is of the same durations. During the transmission, each slot is assigned to a specific message, and only that message can transmit during the slot time. Dynamic segment. The dynamic segment is an optional section of the communication cycle. It is broken down into smaller sections known as a mini slots. If a node wishes to communicate, it must wait until its mini slot comes around. If no transmission occurs after a given period, that mini slot counter is incremented, and the node with the next message or frame ID may begin transmission of data. The data to be sent will only be sent if there is enough time left in the dynamic segment. In this way, a dynamic segment is priority driven, with the message with the lowest ID having the highest priority, just like a CAN. Third one, symbol window. A symbol is used to sign a need to wake up a cluster among other things. This depends on the symbol sent and the status of the controller at the time. Within the symbol window, a single symbol may be sent. If there is more than one symbol to be sent, then higher level protocol must determine which symbol gets priority, as the Flexray protocol provides no arbitration for the symbol window. Network ideal time. The network ideal time is used to calculate clock adjustment and correct the node's view of the global time. It also performs communication specific tasks and uses up the remaining time of the communication cycles. Controller host interface level and host level. Function currently defined include a timer service, an interrupt service, a message ID filtering service, and a network management service. The timer service allows timeouts to be defined for the applications based on the synchronized time base maintained by the protocol. Upon reaching a timeout, the interrupt service raises an interrupt to the host. The message ID filtering services provides means for selecting receive buffers based on the message ID that is exchanged in frame that are enabled for the message ID filtering. This allows using a message selections concept such as in CAN, where message IDs embed the semantical meaning of the associated message. The network management services supports to applications level functional network. Flexray protocol frame format. Header. The frame ID defines the slot in which the frame should be transmitted and is used for the prioritizing event triggered frames. The header CRC is used to detect error during the transfer. The cycle count contains the value of counter that advances incrementally each time a communication cycle starts. Payload. Second, the payload length contains the number of words which are transferred in the frame. The payload contains the actual data transferred by the frame. The length of the Flexray payload or data frame up is up to the 127 words, that means 254 bytes, which is over 30 times greater compared to the CAN as shown in figure. Next one, third one, trailer. The trailer contains 3 8-bit CRCs to detect errors as shown in diagram third. Comparison between the CAN and Flexray protocols. Parameter, first one, access scheme. In CAN, it access to the CSMA or CR carrier sends multiple access collisions resolutions, while in Flexray protocol TDMA, that is the time division multiple access. Second one, focus, event triggered based for small payload, while in Flexray protocol time triggered deterministic behavior based for the medium payload. Automotive applications, ECU, that is the ECU sensors, while in Flexray protocol distributed control systems backbones, while in third parameter, cabling topology. In case of the CAN protocols, we have to use the twisted pair unshielded bus, while in case of the Flexray protocol we have to use the twisted pair unshielded bus or star topology. While redundancy, in case of the CAN there is no any kind of the redundancy, while in case of the Flexray protocol we have the redundancy built in 2 separate channels, that is using twisted pair, twice of the twisted pair. While next one, deterministic behavior for the CAN by extension of the TT CAN, while in case of the already built in the Flexray protocols. Advantage. One of the primary advantage of the Flexray protocol is high data rate. The Flexray bus can achieve a data rates of up to the 10 Mbps, providing a ample bandwidth for the demanding application. While next advantage is that it is deterministic communications, unlike protocol like CAN, which rely on non-deterministic arbitration mechanism. While Flexray uses a time triggered approach, this means that communications occur at a fixed intervals, ensuring predictable and consistent behaviors. The third one advantage is that it offers enhanced the fault tolerance capabilities. The bus architecture with its redundant channels allows communications to continue even if one channel fails. This fault tolerance ensures reliable operations and reduces the risk of communications failures. Next advantage is that it provides support for the larger network topology and scalability. It can handle the complex systems with multiple ECUs, enabling seamless integrations of the various components. Last one advantage, the protocol also offers features like dynamic segment configurations, allowing for the flexible network design and reconfigurations. Applications, there are various applications of the Flexray protocols like vehicle stability controls, vehicle stability assist, or we can say that power systems, system of anti-lock brakes. All these are the applications relevant to the Flexray protocols. Conclusion, we can conclude that the Flexray protocol has revolutionized automotive communications, providing a high-speed deterministic and fault-tolerant solution for the critical applications. With its unique feature and advantage, Flexray found extensive uses in steer-by-wire, brakes-by-wire, or adaptive cruise control and active suspension systems. While the Flexray protocol has its advantages such as high bandwidth, precise timing, it also has its limitations, including higher cost and complexity. The future of the Flexray protocol in automotive will depend on its ability to adapt to emerging technology and the evolving needs of its automotive industry, especially the upcoming challenge from an automotive Ethernet as vehicle becomes more advanced and autonomous. That demand for the real-time communications will continue to grow, providing opportunity for the further development and adoption of the automatic Flexray protocols. These one are the references we have to use for the Flexray protocol. Thank you.